Okay. So today we are going to start October-November 2022 paper 2. Let's start with question number 1. Species such as ammonium ion, carbonate ion, and phosphate ion are examples of molecular ions. Okay. Ionic and covalent bonds both involve an electrostatic attraction between different species. Identify the species that are electrostatically attracted to one another in ionic bond. Yes. Which species are actually attracted to each other when the ionic bond is formed?
Sir, anion and cation.
Yes, anion and cation, or you can write that oppositely charged ions.
ये metals and non metals लिख सकते हैं?
No. Anions and cations, because metal and non-metal is not a species, it's a substance. Or instead writing anions and cations, you may write, or you can write that oppositely charged ions. Now, when we talk about a covalent bond, in the covalent bond, between which species there is an electrostatic attraction between?
Shared non-metal atoms.
No, not atoms.
Nuclei and
Shared pair of electrons
nuclei.
and the two nuclei. Because that electron pair is actually shared between, or is actually present between the nuclei of the two bonded atoms. So the shared pair of electron and two nuclei. Is this understandable?
Yes.
Okay. Now, let's move to the next part. Complete table 1.1 to show the total number of protons and electrons in the molecular ions ammonium, carbonate, and phosphate. So, if you consider over here, let me write the atomic number of both the atoms over here, that both the elements in these molecular ions or polyatomic ions. So nitrogen is 7 and hydrogen atomic number is 1. The atomic number of carbon is 6 and the atomic number of oxygen is 8. The atomic number of phosphorus is 15 and it's again 8. So to find the total number of protons, there is a 1 nitrogen, so there must be 7 and there are 4 hydrogens. So 7 plus 4 gives me 11 protons. Then when we talk about electrons, as it have a positive 1 charge, which means that there is a 1 electron less, so there must be 10 electrons over here. So 11 protons and 10 electrons. Now for carbonate ion, there are 6 protons for a carbon and 8 protons in an oxygen, but there are 3 oxygen, which makes it 24. So the count for the proton would be 24 plus 6, 30. And 2 negative charge indicating 2 extra electrons, so it would be 32. Okay, let me do this over here. So 11 protons, and here 6 plus 8 times 3, 20, no, sorry, 30 protons. Now, in phosphorus, there is a 15 protons, and there are 4 oxygens. So 8 times 4, 32, and 32 and 15 would be
47 and 50.
47. So there are 47 protons, and its charge is 3 negative, which means 3 extra electron, which makes it 50 electrons. Is this clear to everyone?
Yes.
Now, ammonium is a Bronsted-Lowry acid, defined Bronsted-Lowry acid. Okay. So simply you can write a H positive donor, or you can write a proton donor. Both can be considered as a correct. Okay. Then next part, when aqueous ammonium ion is heated with sodium hydroxide, a pungent gas is produced. That pungent gas, the pungent smell gas is basically ammonia gas only. Write an ionic equation for this reaction. Okay. So for the ionic equation thing, ammonium ions are acidic, as they have mentioned over here. And in sodium hydroxide, the alkali is basically the hydroxide ions. So what would happen, that ammonium ion as an acid releases the hydrogen or loses the hydrogen, turning into ammonia gas, and that hydrogen is accepted by the Bronsted-Lowry base, which is hydroxide ion, forming water. So this would be our equation for this reaction. Is this clear to everyone? Yes, if anyone have any doubt, do ask.
Sir, water gas formula?
This is an acid, right? Ammonium ion is an acid, right?
सही है.
So what it do, it turns into ammonia and forming hydrogen ion.
हाँ ठीक है.
This NH3 forms ammonia gas, and this hydrogen ion combines with this hydroxide ion to give you water.
सही.
Is this clear, Asan?
Yes sir.
If anyone else have any doubt, do ask.
तो सर हमने OH क्यों लिया?
Because see, one thing, what they have informed you initially over here, that ammonium ion is an, yes,
Acid.
acid, and acid would react with a base, right?
Yes sir.
So in sodium hydroxide, which is base, basically the
Hydroxide.
that's why we took it. Okay.
Yes sir.
And just give me a minute, please. Okay.
सर एक दफा पूरा डिडक्शन दिखा सकते हैं इक्वेशन का, अपना आयनिक इक्वेशन में कैसे बनाया?
Yes. Yes. I can show that as well. See, there is a ammonium ion, and it is aqueous. right? As they have given you the state symbols. The sodium hydroxide is aqueous as well. Okay. This is alkali, right? And this is an acid. Is this clear?
Yes, sir.
Okay. Now, we know whenever an acid and alkali reacts, what would form? A water would form, right? And as there is ammonium ion, so when the hydrogen is released, a hydrogen ion is released from NH4 positive, the leftover is a ammonia gas, which liberates. And the thing that we left over here is sodium aqueous ions. Now, is this clear?
Yes, sir.
Okay. Now, if you recall, for to make an ionic equation, what would we do? We split the aqueous compounds into ions. So it's already splitted. We don't know whatever the anion is over there with the ammonium. It can be a chloride, or it can be a nitrate, or it can be a sulfate, or it can be a phosphate. It is for sure a spectator ion. That's why the examiner didn't mention. Okay. So aqueous ammonium ion. Then I would split sodium hydroxide into ions. So I would get sodium aqueous ion and a hydroxide aqueous ion. Then on the product side, I have again a sodium aqueous ion. Water or any solid or any gas is or any liquid isn't splitted into ions, it stays the same. So these two, water and ammonia, stays the same. Is this clear?
Yes, sir.
We don't split these. Now, if you look at the whole equation, in the whole equation, this is the ion, which is initially the ion, and afterwards it is also stays the same. There is no change taking place in it. So this is what we call it. We are going to call it a spectator ion. So that's why we cut it down from the equation, and the leftover equation would be your ionic equation. Is this clear now? Yes, Shahriar, Mahveen.
Yes, sir. समझ में आ गया.
If anyone else have any confusion, do ask. Okay. The nitrogen atom in NH4 positive is sp3 hybridized. sp3 orbitals form from the mixing of 1 2s and 3 2p orbitals. One more thing, if sp3 it's sp3 hybridized, then it means in a compound there is all sigma bonds around that atom. Okay, so that is the rule for whether there is a carbon or oxygen or nitrogen. If that carbon, oxygen or nitrogen forming all sigma bonds and there is no pi bond formed by a carbon, nitrogen or oxygen, then that carbon, nitrogen or oxygen is sp3 hybridized. If there is a carbon, oxygen or nitrogen and they are forming one pi bond, then that carbon, and if there is a carbon, oxygen or nitrogen and that are forming two pi bonds, which is actually not possible by I think oxygen, but sometimes it is. So then in that case, that carbon, oxygen or nitrogen is sp hybridized. Now sketch the shapes of a 2s and a 2px orbital on the axis 1.1 axis in figure 1.1. So to make a 2s, what we have to do, we have to make a sphere. And on page we always make a circle instead of a sphere, and then they ask you to draw 2px. So on x-axis, we would make two lobes to form 2px. Is this clear?
सर हम 2s को दिखाने के लिए एक अंदर छोटा 1s नहीं बनाएंगे?
No, there is no necessity to show 1s inside it. Okay.
सही.
Okay. There are many naturally occurring hydrated compounds that contain phosphate ions. Name the anion phosphate. Okay, I have told you. So, if it's a phosphate, so how would I name it? It's phosphate, and in redox, we would, discuss the naming. So, if you work on the phosphate, what you are going to find that there is a +5 oxidation number on phosphorus over here. So we would write phosphate 5 ion. Is this clear?
Yes, sir.
Okay, just give me a minute. Now, next part. Struvite is a soft hydrated mineral.
सर फॉस्फेट का 1+ होता है?
What 1+? It's 5+.
वो नहीं होता 1+ है. यहाँ पे 5+ होगा.
What 1+? I didn't understand, Abdullah.
नहीं मतलब फॉस्फोरस ग्रुप 1 में ना.
No, phosphorus is in group 5. It's group 15.
अच्छा.
So the net charge is -3, right?
जी.
Oxygen have -2. There are 4 oxygen, which makes -8, and the net charge is -3. So what would be the charge over here? It must be +5. That's why we are getting -3 over here. That's why phosphate 5 ion.
सही है.
Okay. Now, struvite is a soft hydrated mineral with the MR 24.2 45.3. The anhydrous form of the mineral has the formula NH4Mg-ClO4, so ammonium magnesium phosphate. Calculate the number of molecules of water of crystallization in struvite. Give your answer to the nearest integer, show your working. So it would be very easy. That is the MR of hydrated one, and they have given you the formula of anhydrous. So from the formula of anhydrous, I can find the MR of anhydrous ammonium magnesium sulfate. So ammonium is 17, no, 18. Magnesium is 24 point. Can anybody confirm that its AR is 24.3 or 24.1? Phosphorus is 31, and there are 4 oxygens, which makes it 64. Yes. What is the AR of magnesium? Yes.
सर 24.3 है.
Okay. So can anybody calculate the MR over here? Yes.
सर 137.3 है.
137.3. So see, this is the MR of magnesium, this steroid. So see, for example, if I know the MR of hydrated steroid, and the formula of the hydrated steroid would be this, and I have to find this value, right? So if I subtract the MR of anhydrous steroid from the hydrated one, I am going to get the mass of water, right? So its MR is 245.3 minus 137.3. Yes, can anybody tell me the answer, please?
$108.
108. So if I turn this mass into moles, I would get the value of this X over here. So 108 divided by 18. What would be the answer? Yes, 6. So the number of molecules of water of crystallization would be 6. So it means the formula for the hydrated steroid is ammonium, magnesium phosphate, and hexa-H2O, 6H2O. It would be like this. Is this clear?
Yes.
Yes.
सही जो हम लोगों ने कैलकुलेट करे ये मोल्स नहीं थे?
Now we have calculated the mass of water in 1 mole of the compound, right? So if I get turns into moles, then it would be the value of water over here, because see, in this formula, this X is actually the moles of water that is present with 1 mole of this compound.
ओके सर, समझ गए।
सर मोल्स का मैक्सिमम कितना मार्क्स आ जाए क्वेश्चन?
If you see, if you have practiced yourself, you didn't find the total moles. I think they are not more than, sometimes of 8 marks or 10 marks maximum, but very rarely. Otherwise, it's not more than, I think, 5 to 6 marks. Okay. So now part E. Hydroxide aqueous ions reacts with 2-bromo 2-methyl propane in a SN1 reaction. And if you recall the SN1 reaction, it is a 2-step in which the first step is the formation of carbocation, and in the second step, nucleophile attacks. The molecular ion forms as an intermediate in this reaction. Okay. Draw the mechanism for the SN1 reaction of hydroxide ion with 2-bromo 2-methyl propane. Include the charges, dipoles, lone pairs of each electron, and curly arrows as appropriate. Draw the structure of the organic reactant and organic product. Okay, so if you see, they have missed both the things. They have shown you the intermediate carbocation, and if you see the name of the reactant, what it is 2-bromo 2-methyl propane. So as it's propane, so it must be a 3-carbon chain, and on a second carbon there is a bromine and there is a methyl. So there are all the 4 bonds of the second carbon is completed. Now the carbon on the left one and the carbon on the right one both have a 1-1 bond, so it means there must be 3 hydrogens on both of them. So see, we got the structure of our reactant. Okay, now we have to show the dipoles over here. So for dipoles, that carbon must be partial positive because it is bonded to a bromine, which is more electronegative, so it must be partial negative. Then, as a carbocation is formed over here, the carbon have a positive charge, which is indicating that the carbon basically lost its electron to a bromine. So bromine basically breaks this bond heterolytically by taking away the pair of electron, the bond pair of the electron. As a result, it took away the electron of the carbon. That's why carbon becomes a positively charged. Is this understandable to everyone?
Yes.
Now, we are reacting it with the aqueous hydroxide ion. So that hydroxide ion is actually, the nucleophile, and this nucleophile have a lone pair, so it is going to attack to a carbon with its lone pair, and as a result we would obtain the product and that is our product. Is this understandable to everyone?
सर ब्रोमीन नहीं दिखाएंगे लोन पेयर के साथ एक प्लस करके?
1 minute please. Yes, so yeah, that bromine can be shown over here, that it gets away, but it is not necessary to show it.
अच्छा सर, रीजेंट्स के मतलब एरोज में वो मतलब कंडीशन और वो नहीं देना और मैकेनिज्म के उसमें कंडीशन और वो सब कुछ नहीं लिखना होता एरोज के ऊपर?
No, whenever examiner
Sorry.
asks you to mention the conditions, then you have to, in mechanisms there is no conditions mentioned in the mechanisms. Okay, now 2-bromo-2-methyl propane is a tertiary bromoalkane. Define tertiary bromoalkane. So what we have defined, what I have told you, if you recall, the carbon which is bonded to a bromine, if already bonded to 3 more carbons, then it's a tertiary one. If it's bonded to 2 more carbons, then it's a secondary one. And if it's bonded to 1 carbon or all the hydrogens, then it's a primary one. So here I write that the carbon that is C bond Br. It means I'm talking about this carbon bonded to 3 more carbons. So it's a tertiary bromoalkane. Is this clear?
Yes sir, मिथाइल ग्रुप भी लिख सकते थे ना?
No, we are talking about generally they have talked about to just define tertiary bromoalkane. If they have talked about, or if they have asked you why 2-bromo-2-methyl propane is a secondary, is a tertiary, so then we can write that because the carbon in this compound which is bonded to a Br have a 3 methyl groups. If they have asked you specifically that why 2-bromo-2-methyl propane is a tertiary bromoalkane, then you can mention methyl, but here they have asked you the general definition of tertiary bromoalkane.
सर तो अल्काइल लिख सकते हैं?
Yes, alkyl can be written. Instead, if you write 3 more carbons, instead you can write 3 more alkyl groups. That is fine over here because they are.
Oh yes, sorry, मैं भी अल्काइल बोल रहा था, मैंने गलती से मिथाइल बोल दिया.
हाँ, okay. So methyl can be written when they specifically asking you why this is. Okay. Now next part, organic compound M forms when 2-bromo-2-methyl propane is heated with ethanolic hydroxide. Draw the structure of M. So if you recall, when we heat with ethanolic hydroxide, elimination would occur. With aqueous sodium hydroxide or with aqueous hydroxide, nucleophilic substitution occur. With aqueous, with ethanolic hydroxide, elimination would occur. So, if there is an elimination and our compound was this, on the all the three sides there are methyl groups, and here there is a bromine. So bromine from here and hydrogen from any one place would be removed to form HBr, and we are left with
सर एलिमिनेशन कैसे पता चल
this structure. Why we had identified the elimination? By this only. Ethanolic hydroxide.
Sure.
See over here. 1 minute. I have shared the spider diagrams with you. See over here. There is a halogenoalkane, right? We are using sodium hydroxide aqueous. What is happening? That halogen is substituted by OH, and that's why it's a nucleophilic substitution, because sodium hydroxide is an aqueous medium, right? And if you see over here, here it is. See on the top. No, over here. In this reaction, we are using ethanolic sodium hydroxide, and then elimination would occur, forming a double bond. So the condition would help us to identify whether it's a nucleophilic substitution of a halogenoalkane or a elimination of a halogenoalkane. Is this understandable?
Yes.
Okay.
सर आप इस स्पाइरल डायग्राम दोबारा शेयर कर सकते हैं, मुझे नहीं दिख रहा।
Sorry.
सर जो स्पाइरल डायग्राम है वो आप दोबारा शेयर कर सकते हैं।
Okay, I will share it again, but if you see, you go in the description and go through the documents, I think you can find.
चलिए सर, I'll find it.
Otherwise, I will share in the group again. No issues. The chlorides of the sum of the period 3 elements are shown in table 2.1. Okay. Complete the table 2.1. There are empty spaces over here. Identify the bonding shown by each chloride under standard conditions. Use C for covalent, I for ionic, and M for metallic. Okay. Identify the structure of each of the chloride under standard conditions using G for giant and S for simple. Reduce the oxidation state of the period 3 elements in each of the chloride. Okay. So sodium chloride is a ionic one. So I would write I. Aluminium chloride is a covalent one. Or basically it can a covalent as well as ionic as sometimes. So for aluminium chloride, ionic and covalent both can be accepted. For silicon chloride, it's a metalloid.
कोवेलेंट प्रॉपर्टी शो करता है ना।
Sorry.
एल्युमिनियम क्लोराइड तो आयोनिक बॉन्ड फॉर्म करता है, लेकिन कोवेलेंट प्रॉपर्टी शो करता है खाली।
You are mixing with aluminium character. Not ionic, not aluminium chloride. Aluminium chloride is a simple molecular. If you recall, the dot and cross we have discussed in the our classes where the aluminium is electron deficient because 3 chlorines are bonded to it, sharing 3 electrons. So as a result, aluminium just got a 6 electrons around it instead of being 8 electrons, right? And that's why it form a dative bond with another aluminium chloride molecule forming Al2Cl6. Remember?
Yes, sir.
So aluminium oxide forms ionic bond with a covalent character, but aluminum chloride normally shows covalent bonding, but sometimes it can also show ionic bonding as well. Now, structure. Sodium chloride is a ionic one, so ionic are giant. Silicon chloride, if you recall, SiCl4 is a simple molecular structure, and PCl5 is also a simple molecular structure. Aluminum chloride, when it's covalent, it also shows simple molecular, and when it's a ionic, it shows giant. Now comes to the oxidation state. Look over here. Zero, there is with a -1, so -1. Net charge is 0. There are 3 chlorides with each one -1, which makes aluminium +3. Again, the net charge is 0. There is 4 chloride, each with -1, which makes silicon +4. The net charge is 0. Each chloride have a -1, and there are 5 chlorides, which make this phosphorus +5. The net charge is 0, -1. 3 are there, which makes it +3. Net charge is 0. 2 chlorine are there, 2 chloride are there, which makes sulfur +2. So over here, +1, +3, +4, +5, +3, and +2. Is this clear?
Yes, sir.
Yes.
Okay. Now, write equations for the reaction of sodium chloride and PCl5 with water. Include state symbols in both the equations. Okay. So, if you recall about sodium chloride, it's a solid one. When it dissolves in water, it just dissociates into ions, so forming a sodium ion in the aqueous state and the chloride ion in the aqueous state. Nothing else happened. But PCl5 is a covalent compound, so covalent compounds hydrolyzed in water. Hydrolyzed means they react with water. So when it reacts with water, so you have to, it's a solid, so you have to show water over here as well. And when it reacts with water, it would give you phosphoric acid, H3PO4, which must be aqueous, and HCl, aqueous. So if you balance the equation, there are 5 chlorine, so you would put 5 over here, and there are 4 oxygens.
सर ये PCl5 में POCl3 भी नहीं बनेगा?
1 minute, Shahan. 4 water. Yes, now the equation is balanced. Yes, what you are talking about, it is the first stage of this reaction. If you recall, first PCl5 reacts with water to form POCl3 and HCl. If you balance this equation, you have to put 2 over here, and there is a 1 mole of water. So that POCl3, when formed, it continues to react with water, and here you are going to get phosphoric acid, H3PO4, and HCl. So see, there are 3 chlorines, which makes it over 3. There are 6 hydrogens, so I would put 3 over here. Now, look over here. The reaction actually occurs in 2 steps. So if I add both of them, I would cancel out this POCl3 and this POCl3. Now, if you see, we are left with PCl5, 3 + 1, 4 water molecules. There is no POCl3 on the product side as well. I would get H3PO4 phosphoric acid and 5 moles of HCl. See the above equation I have made.
सर ये भी NaCl की तरह डिसोसिएट नहीं हो जाता?
Sorry,
ये भी NaCl की तरह डिसोसिएट क्यों नहीं होता पानी में जाके?
because it's a covalent compound. Ionic compound dissociates in water, and if
सही
you
है.
further recall, we have discussed in besides sodium chloride, magnesium chloride also undergo reaction releasing the hydrogen ion and making the pH 6. And aluminum chloride also do this.
अच्छा.
That's what we have discussed in period 3. See over here. See, here we have the reactions. Sodium chloride with water, it just dissociates. See, magnesium chloride undergo this reaction. When the examiner asks you about the equation for the magnesium chloride with water, you have to write this equation. And you have to remember the pH values as well. Here the pH is 7, here the pH goes from 6 to 6.5. In the same manner, when the aluminum chloride reacts with water, this would happen. That is your net equation, and the pH of the solution, if examiner asks you, it would be 2:3. Then further, I have discussed when examiner asks you the comparison, if examiner asks you to compare the solubility or dissolving of magnesium chloride and sodium chloride, we would write that sodium chloride just dissolves, and for magnesium chloride, we would write that it reacts. But in the same manner, if the examiner asks you to compare the dissolution or the dissolving of magnesium chloride and aluminum chloride, then in that case for magnesium chloride you just write that it dissolves, and for aluminum chloride you just write it reacts. But after aluminum chloride, all are the covalent ones, so the covalent ones always react in water, hydrolyzed in water. See, SiCl4 is reacting with water, PCl3 is reacting with water, PCl5 is reacting with water, and we are getting this. Okay, is this clear?
सही है सर.
Okay, now C part. In the gas phase, aluminum chloride gas exists at equilibrium with Al2Cl6 as shown. Okay, so here there is a dative bonding, and here it's just a simple covalent bonding. Complete the dot and cross diagram to show the bonding in Al2Cl6. Okay, so first complete the one aluminum chloride molecule, AlCl3. So the dotted electrons are of chlorine, right? So this one is from aluminium. 3 lone pairs each chlorine atom have. In the same way, aluminium shares its third electron with the third chlorine atom. Now, see, it's AlCl3, right? But if you recall, okay, let me do one thing. This is one aluminum chloride, okay? Molecule, AlCl3. Here I have another aluminum chloride molecule. First I am making separately to make you guys understand what will happen. There is a chlorine sharing its one electron with the aluminium, and rest of the 3 lone pairs are over here. Then here I have another chlorine atom sharing its one electron with the aluminium. And here we have another chlorine atom sharing its one electron with the aluminium. So these are two aluminum chloride molecules. They ask you to show the bonding in aluminium chloride Al2Cl6. So what would happen actually over here? That it would happen like this. That this aluminium is forming a covalent bond with this chlorine is forming a covalent bond with the aluminum of the first aluminium atom of the first molecule, and this chlorine atom is forming a covalent bond with the aluminium of the second molecule. Is this understandable to everyone? This is the diagram that we have discussed in our bonding as well, dative bonding. You can find this example in the dative bonding notes. Is it clear? If anybody have any doubt, do ask. Yes.
सर पुराने वाले एल्यूमिनियम के साथ डेटिव बॉन्ड नहीं बनेगा?
See, this is the dative bond. And this here it is a dative bond. Because see, this chlorine is sharing a whole pair of electron with this aluminium, and in the same way this chlorine is sharing this whole pair of electron with this aluminium.
सर तो डेटिव बॉन्ड का तो मतलब ये नहीं होता कि वो पूरा अपना लोन पेयर दे देते हैं?
So that's what happened. That's what happened. See, there is a both the electrons are dotted one, which means that belongs to chlorine. There is no electron from the aluminium over here.
सही.
See, these are not dative bonds because one electron is dot and one electron is cross, which means that it's a simple covalent bond because both the atoms sharing their electron with each other. But here in this case, which I highlighted, if you see this, this pair, there is a pair which comes from the chlorine only, and this pair is also coming from the chlorine only, right? Is it clear now?
Yes.
Okay. Now, state the effect of an increase in temperature on equilibrium mixture in equation 1. Yes. Can anybody recall when we increase the temperature where the equilibrium would shift?
Equilibrium would shift to the left.
Sir, endothermic side.
Why? Equilibrium would shift to the endothermic side, and in this case, the forward reaction is exothermic. Yes, so the equilibrium would shift to the left. So I can write that equilibrium to the left on increasing temperature as forward reaction is endothermic. Is this understandable to everyone?
Sir, forward exo है.
Yeah, sorry. Thank you. Forward reaction is exothermic, that's why. Or instead you can write that the backward reaction is endothermic, then it is also considered as correct, okay? Is this clear?
Yes, sir.
Okay. I think we will keep the class till here today. Tomorrow we will continue further. Okay. Okay. Take care,
Okay, sir.
everyone. Allah Hafiz.
Hafiz, sir.
Allah Hafiz.